Hi all, welcome to Anil Nair classes. Today in this session, we are going to discuss the solved example for the divisibility rule for selected prime numbers. We have already discussed how to find the divisibility rule for few numbers which comes very frequently in the examination. Today I will show you the application part of the concept that we discussed. Today is divisibility rule session 3. Session 4. In session 1, I will repeat it again. In session 1, we discussed the divisibility rule for 2, 5, 10. We discussed the divisibility rule for 2 power n, 5 power n and 10 power n. We also discussed the divisibility rule for 11. This is what we discussed in session 1. In session 2, we discussed the theory of osculation. Theory of osculation. What does the theory of osculation states? If AB is any number, if you can write this number as A plus or minus K into B as 0 or AB, then you can find out the divisibility rule for any prime number. In session 3, we discussed the divisibility rule for 7, 11, 13, 77, 91, 143 and 1001. We discussed the divisibility rule for 99, 101. We discussed the divisibility rule for 73. We discussed the divisibility rule for 41. We also discussed the divisibility rule for 271 and also for the 371. We also discussed the divisibility rule for 17 and 19. These are the some concepts which we discussed. In session 3, we only discussed the concept behind finding the divisibility rule for 7, 11, 13, 17, 19. Ramu, Praveen, కొంచెం మెల్ల మాట్లాడి నాకు డిస్టర్బెన్స్గా ఉంది. రైట్. We discussed the divisibility rule for the concept for 7, 11, 13, 77, 91, 143, 1001, 99, 101, 73, 41, 271, 371. Now in divisibility rule session 4, we will discuss the application part of the concept that we discussed. Extremely important class. Listen carefully. How am I using that concept to simplify the problems? Now, those of you are relatively new to my YouTube live classes or you are seeing it for the first time because somebody has referred you. My name is Anil Nair. I was the ex-Career Launcher South India academic head and I have taken session more than 1000 students minimum 500 times. Right? Kindly sit in my class with a notebook and a pen or a pencil because most of the concepts you will not find it in the regular textbook or any of the channels that you subscribed. Watch the entire lecture and to get the maximum output from the lecture, please write down the important key points. At the end of the session, you will be able to eliminate the usage of pens and pencils and use the fullest power of your brain. The way you look at aptitude, I am going to change it with a series of YouTube live classes. In case if you got any doubts, please send us a mail at support@anilnairclasses.com. Straight away we'll get into the class. I'm sure most of you know it. We are ranked number 1 in Google reviews all over India. Right? If you can type Anil Nair classes Bangalore reviews, Anil Nair classes Bangalore reviews, you can see all these reviews what the students keep talking about me. I will just repeat it once again. Divisibility rule for 7, 11, 13. I will just recap the important concept. Divisibility rule for 7, 11, 13. It is also useful for 77, 91, 143 and 1001. What is the concept? 10 power 3 divided by any of these numbers 7, 11, 13, 77, 91, 143 and 1001. These are nothing but minus 1. This is the concept. Start from the right hand side take a group of 3 digits, take a group of 3 digits, take a group of 3 digits, alternatively add and subtract, alternatively add and subtract. That is the divisibility rule for any of the numbers. Alternatively add and subtract. This is the divisibility rule for 7, 11, 13, 77, 91, 143, 1001. These are nothing but the combinations of 7, 11, 13 taken two at a time or taken all together. Are you all with me? This is the concept which we are going to use. First problem, listen carefully. First one, right? Before that there is also a divisibility rule for 27 and 37. That also we will discuss. So next concept is divisibility rule for 27 comma 37. Divisibility rule for 27 comma 37. 27 into 37 is 999. 27 into 37 is 999. 10 power 3 divided by 27. 1000 is nothing but 999 plus 1 when divided by 27. 999 divided by 27 is remainder 0. So answer 1. Similarly, remainder 1. 10 cube divided by 37, it is 1. I hope it is clear, because 27 into 37 is 999. 10 cube divided by 27 is 1. 10 cube divided by 37 is 1. Because 10 cube is 999 plus 1. So idea is, start from right hand side. Start from right hand side. Take a group of 3 digits. Start from right hand side. Take a group of 3 digits. Take a group of 3 digits. Add them. Start from right hand side, take a group of 3 digits, add them. That is the divisibility rule for 27 comma 37. That is the divisibility rule for 27 comma 37. These two important key points are there. Once you know this concept, this is a very easy problem. 27 and 37 divisibility rule is, take a group of 3 digits, add them. Take a group of 3 digits, add them. Now we will apply the same thing to this one. There is a number that is given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. First question is, what is the remainder when you divide a number by 27? Number is divided by 27. Number divided by 27 is, take a group of 3 digits, starting from rightmost. Take a group of 3 digits. Take a group of 3 digits. Add them. Take a group of 3 digits and add them. So these are nothing but 123 plus 456 plus 789 plus 101 plus 112. How to add these numbers? Right? You don't need to add 123 plus 456. One is there in hundreds place. 100 plus 400, 500. 500 plus 700, 1200. Plus 100, 1300. Plus 100, 1400. So this will become 1400. 1400. I worked with the hundreds place. Tens place. These 20. These 50. 20 plus 50, 70. 70 plus 80, 150. 150 plus 10, 160. I worked with the tens place. Units place. 3 plus 6, 9. 9 plus 9, 18. 18 plus 1, 19. 19 plus 2, 21. So these are nothing but 1581. Are you all with me? I worked with hundreds, right? 1 is there in hundreds place, 4 is there in hundreds place, 7 is there in hundreds place, 1 is there in hundreds place, another 100 plus 400, 500 plus 1200, 1300, 1400. Then working with the tens place. 20 plus 50 plus 80 plus 10. Then working with the units place. 3 plus 6, 9, 9 plus 9, 18, 19, 21. So the first one answer is remainder 1, 1581 divided by 27. Divisibility rule of 27 is, take a group of 3 digits and add them. So this is nothing but 582 divided by 27. 27 twos are 54. 42. 27 ones are 27. Remainder is 15. First one answer is 15. I hope the idea is clear. Take a group of 3 digits, add them. That is the divisibility rule for 27. I hope the idea is clear. How to add these number also it is clear. Question 2. Find the remainder when you are dividing a number by 37. So same thing I will get. Remainder 1. Till here it is same. 582 divided by 37. 37 ones are 37. Remaining is 212. 37 6 are 222 minus 10. If it is a negative remainder minus 10, positive remainder will be 27. Second one, answer is nothing but 27. First one, answer is nothing but 15. I hope the idea is clear. What is the divisibility rule for 27 and 37? Start from the right hand side. Take a group of 3 digits and add them. Take a group of 3 digits and add them. Idea clear, right? Crystal clear idea. Very easy question. How to add these number? First I worked with the hundreds place. Then I worked with the tens place. Then I worked with the tens place. Then I worked with the units place. Units place is nothing but 3 plus 6 plus 9 plus 1 plus 2. Idea clear, right? First and second application of divisibility rule for 27 and 37. First question it is clear. Second one. Find the remainder when n is divided by 7, 11, 13. Now I will put a slash here. These 3 uses one concept. These 2 uses one concept. Question 1, 2, 3. Question 1, 2, 3 is nothing but what is the concept that we are using? 10 cube divided by 7 or 11 or 13, which is nothing but minus 1. 10 cube divided by 7 or 11 or 13 is minus 1. Now if you see question, 100 is there, 101 is there, 102 is there, 999 is there. 999 is there. Total how many numbers are there? Total how many numbers are there? Total number of numbers is given by highest value minus lowest value plus 1. 100 is the highest value, 999. Lowest value is 100 plus 1. So total 900 numbers are there which are written in the sequential order. Are you all with me? So the first one, total how many numbers are there? 900 numbers are there. Suppose question 1. Suppose if you see 100, 101, 102 and so on up to 998, 999. Take a group of 3 digits alternatively plus minus. Take a group of 3 digits alternatively plus minus, alternatively plus minus. Total 900 numbers are there. I am taking 2 numbers, 998, 999. Alternatively add and subtract. 999 minus 998 is 1. 997 minus 996 is 1. Out of 900 numbers, 2 numbers I am taking it as a doublet. 2 numbers if I do alternatively add and subtract, I will get 1. So 1, 1, 1. 900 I am taking 2 numbers at a time. So total 450 I will get it. So remainder 450 divided by 7. So these are nothing but 7 6 are 42, 30. 7 4s are 28. Remainder is nothing but 2. Remainder is nothing but 2. Are you all with me? Again I am explaining. The lowest number that I wrote in this is 100. Highest number which I wrote in this is 999. Lowest is 100, highest is 999. Total numbers that I wrote is highest minus lowest plus 1. Total 900 numbers I wrote. In these 900 numbers, start from the right hand side. Alternatively add and subtract. 998 minus 998 is 1. 997 minus 996 is 1. That means if I wrote 4 numbers, I got 2 ones. If I wrote 6 numbers, I got 3 ones, which is half of 6. If I wrote 8 numbers, I will get 4. If I wrote 900 numbers, I will get half 450. 450 divided by 7 is 2. First one answer is 2. I hope the idea is clear. Second idea, what we will do is just a small change. I will get the answer. Second one, if you see 450 divided by 11. Second question. 11 fours are 44, 10. So answer is 10 is the second one. I hope it is clear, right? 450 divided by 11 is nothing but minus 1 is the remainder, because 451 is divisible by 11. Negative remainder minus 1, positive remainder 10. Second one also over. Third one, small change, you will get the answer. 450 divided by 13. 13 threes are 39, 60. 13 fours are 52, 8. Third one, it is 8. I hope it is clear. First three logics are 10 power 3 divided by 7, 11 are 30. Negative remainder is 1, minus 1. So negative remainder minus 1, from there you can use it. Next one. So first three are over. First three we discussed. Take a group of 3 digits, alternatively add and subtract. Question number 4 and 5. Logic is remainder 1, 10 power 3 divided by 27 or 37, it is 1. 27 or 37, it is 1. So here it is 999, here it is 998, and so on up to 100. Take a group of 3 digits, add them. Take a group of 3 digits, add them. So take a group of 3 digits, add them. So answer is nothing but 100 plus 101 plus 102 and so on up to 999. The series is in arithmetic progression. Arithmetic progression is n by 2 into first term plus last term. So n total numbers are present are 900. 900 by 2 into 100 plus 999, which is nothing but 1099. So these are nothing but 450 into 1099. I hope it is clear, right? So these are nothing but the sum of this number. So what is question number 4? Question number 4 is what is the remainder when you divide a number by 27? 450 into 1099 divided by 27. 27 divisibility rule is take a group of 3 digits and add them. 990 plus 1 is 100. So 100 into 450 divided by 27. Whatever the answer that you will get, that itself is the answer. 27 fours are 108, minus 8. 27 ones are 27, 180. 27 six are 182, minus 2. Minus 8 into minus 2. So fourth one answer is 16. Fourth one answer is 16. I hope it is clear. Sum of n terms in AP is nothing but n by 2 into first term plus last term. N by 2 into first term plus last term. This value 100 into 450 will not change for question number 5. Question number 5 also we will solve it here only. Question number 5. What is question number 5? Find the remainder when n is divided by 37. So here it is 100 into 450 divided by 37. So 37 twos are 74, 26 into 37 ones are 37, 80. 37 twos are 74, 6. So 26 6 are 156. 156 when I further divided by 37. 37 fours are 148. So answer is 8. Fifth also it is over. It is nothing but a simple calculation approach. Only thing what you should know in this question is 10 cube divided by 7 is minus 1. 10 cube divided by 11 is minus 1. 10 cube divided by 13 is also minus 1. That is the divisibility rule for 1, 2 and 3. 4 and 5 is 10 cube divided by 27 is 1. 10 cube divided by 37 is also 1. Idea clear? 1, 2, 3, 4, 5. Next one. Next question is based on 259, 351, 176. 259. 259 is written as 7 into 37. 7 into 37. What is the next number? 351. 351. 351 is nothing but 13 2s are 26. 91. 13 7s are 91. What is the next one? 176. 176 is nothing but 11 into 16. 11 into 16. Now in the next question it is a combination of 7, 11, 13, 37, 27 and everything. Now we will see this question. What is the question value that is given? 4 written 73 times. So 4, 4, 4, 4, 4. 4, 4, 4, 4, 4 written 73 times divided by 259. Divided by 259. Now see here. Any single digit written in groups of 6. Any single digit written in groups of 6 is always divisible by 7. Any single digit written in groups of 6 is always divisible by 7. 259 is 7 into 37. So if it is 7, 4 written 6 times it is 0. 4 written 12 times it is 0. What is the multiple of 6 till 73? 6 12s are 72. How many 4s are remaining? 1 4 is remaining. That means if 4 4 4 4 4 4 written 73 times, when divided by 7, I will get 1 4 remaining, because if 4 is written 6 times, remainder is 0. 12 times the remainder is 0. 72 times the remainder is 0. But the question is 73. That means 1 4 is left. Are you all with me? Next one. I hope this concept clear. Any single digit written p minus 1 times, this also you can use, is always divisible by p. P is not equivalent to 235. P is not equivalent to 235. If you take a prime number, p is a prime number. Any single digit written p minus 1 times is never always divisible by p when p is a prime number. When p is a prime number. I hope it is clear now. That means if 4 is written 36 times, if 4 is written 36 times divided by 37, remainder will be 0. Not only 36 times, what is the next multiple of 36? 72 times, remainder is 0. That means 4 4 4 written 72 times divided by 37, it is 0. So but the question is 4 is written 73 times. 4 written 73 times divided by 37. 36 times it is 0. 72 times it is 0. One more 4 is left. That means when you divide a number by 7, you got a remainder 4. When you divide a number by 37, you got a 4. So when divided by 7, remainder is 4. When divided by 37, remainder is 4. Both are equated with the same number. 4 4 cancel. A is 0 or B is 0. So 0 into something plus 4, answer is 4. Very good question. You don't need to do all this. Directly you will get the answer if you understand this approach. Any single digit written p minus 1 times is always divisible by p if p is a prime. P is not equivalent to 2, 3 and 5. Any single digit written p minus 1 times is always divisible by p if p is prime, p not equivalent to 2, 3, 5. If it is 7, top it will become 6 times. What is the multiple of 6 till 73? 6 12s are 72, remainder 1. So another 4 is left. If it is 37, numerator it will be 36 times. 36 2s are 72. How many left? 1. So again one more is left. Very good question. Divisibility rule for 259 is nothing but the combination of 7 and 37. 7 and 37. First one answer is nothing but 4. First one answer is nothing but 4. Second one, question number 2. Question number 2. Find the remainder when number is divided by 351. Now 351 is nothing but 13 2s are 26, 91, 13 7s are 91. 13 into 27. What is the divisibility rule for 13? Take a group of 3 digits, alternatively add and subtract. Or what is the another divisibility rule? Any single digit written 12 times, written in groups of 12, is always divisible by 13. That is what we had said. Any single digit written p minus 1 times is always divisible by p if p is prime. So 73 is 12 6 are 72. Remainder 1. Remainder 1 4 is left. That means 13 when it is divided by number is divided by 13, I got 1 4 left. 13a plus 4. Next one 27. 27 is nothing but 10 cube divided by 27 is 1. So if I take it into a groups of 3, 4, 444 and so on. So this is nothing but 24 groups of 244. Can I write? 444 is a 3-digit number. 3-digit number written 24 times. 3 24s are 72. One more 4 is left when divided by 27. So take a group of 3 digits and add it. So answer is nothing but remainder of 4 plus 444 into 24 divided by 27. Are you all with me? Divided by 27. 444 is 111. That means any single digit written in groups of 3. Any single digit written in groups of 3. It is always divisible by 27. Are you all with me? Any single digit written in groups of 3. It is always divisible by 27. Why? Because 444 is 4 into 111. 111 is 4 plus 444 into 24. In this case, what it will become is any single digit written in groups of 3. Groups of 3 power n is always divisible by 3 power n. Any single digit written in groups of 3 power n is, I will come back to that point. What am I saying? Please understand it. These 4 into 111. These nothing but 8 is nothing, 24 is nothing but 3 into 8. 3 into 8. Now if you see, I hope it is clear, right? 4 plus 444 into 24 divided by 27. Now, are we getting these nothing but 333? Or what you do is you just multiply it. 27 ones are 27. 174. 174 is 27. 6 are 162. Remainder is 12. Remainder is 12. So 12. 4 plus these 12. 12 into 24 divided by 27 is minus 3 divided by 27. Minus 36 plus 4 is minus 32. 32 divided by 27 is 5. Minus 5. Positive remainder is 23. I hope it is clear, right? Again I am repeating. 351 is 13 into 27. Any single digit written in groups of 12 is always divisible by 13. Groups of 12 means 73. 12 6 are 72. 1 4 is left. 1 4 will be left. Here when divided by 13, 1 4 is left. Check with the answer option. We are doing it by 27. 27 is nothing but take a group of 3 digits, add 1. 444 is a 3 digit number. 24 groups will be there. 4 plus 444 into 24 divided by 7. 23. Equate both the equations, you will get the answer. I hope idea is clear. If it is not clear, I will do one more example so that it will be clear. Idea is to use the divisibility rule for 13 and 27. Logic clear? Question number 3. Question number 3. Question number 3 is 176. 176 is 11 into 16. 11 into 16. 11 into 16. Now, what is the concept that we used for 11? Any single digit written in groups of 10. Any single digit written in groups of 10. Any single digit written in groups of 10 is always divisible by 11. Any single digit written p minus 1 times is always divisible by p if p is a prime number. So 10 sevens are 70. Remainder is 3 more are there. 444 divided by 11. 11 fours are 44. Remainder is 4. 176 is 11 into 16. 11 I got the remainder 4. 11 I got the remainder 4. Next it is 16. 16 means what is the divisibility rule for 16? Last 4 digits. Last 4 digits should be divisible by 16. Last 4 digits should be divisible by 16. 2 means unit digit should be divisible by 2. 4 means last 2 digits should be divisible by 4. 3 means last 3 digits should be divisible by 8. 4 means last 4 digits, which is nothing but 44444 divided by 16. 16 twos are 32. 124. 16 sevens are 112. 16 means 16 twos are 32. 124. 124 means minus 4. Minus 44. 16 threes are 48. Minus 4. Minus into minus plus. 4 is the remainder. Again see how am I doing. 16 threes are 48. Minus 44. Minus 444 divided by 16. 16 threes are 48. Minus 44. 16 threes are 48. Minus 4. Minus into minus plus. That means when divided by 16, what is the remainder? 4. When divided by 11, what is the remainder? 4. 11a plus 4 equivalent to 16b plus 4. 4 cancel. A0, B0. Answer is 4. All are these advanced level questions. 176 is 16 into 11. 351 is 13 into 27 and 259 is 7 into 37. Very, very important concept. Any single digit written p minus 1 times is always divisible by p if p is a prime number. That is the concept I used it. For 16, what is the divisibility rule? Last 4 digits should be divisible by 16. Little bit of calculation based problem it is. Little bit of calculation intensive problem. Be little careful while solving the problem. Calculation intensive. Next one I am doing remainder 1 divisibility rule for 101 and 99. Divisibility rule for 99 comma 101. So this will become remainder 1. 10 square divided by 99 is 100 divided by 99 is 1. Remainder 1. 10 square divided by 101. 100 divided by 101 is minus 1. That means what will be the divisibility rule? Start from right hand side. Take a group of 2 digits. Add them. That is the divisibility rule for 99. Add and subtract them. That is the divisibility rule for 101. Are you all with me? Start from right hand side, take a group of 2 digits, add them. That is the divisibility rule for 99. Add and subtract them. That is the divisibility rule for 101. Another important point. Any two digit number written even number of times, any 2-digit number written even number of times is always divisible by 101. Any 2-digit number written even number of times is always divisible by 101. Why it is divisible by 101? 1212 divided by 101. These 12 into 2, 10 square plus 12 divided by 101. 10 square divided by 101 is minus 1. Minus 12 plus 12 is 0. Any 2-digit number written even number of times is always divisible by 101. Any 2-digit number written even number of times is always divisible by 101. If it is the divisibility rule for 99, start from right hand side. Take a group of 2 digits, add them. I hope it is clear, right? Take a group of 2 digits. I am not well, I am suffering from cold, please cooperate it. 10 square divided by 99 is 1. This is the concept. Now let us solve the problems. What is the remainder when n is divided by 101? Same concept, remainder when 10 square divided by 101. 100 divided by 101 is minus 1. So these are nothing but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on up to 38, 39, 40, 41, 42 divided by 101. So these are nothing but 41, 42. Take a group of 2 digits, alternatively add and subtract. 42 minus 41 is 1. Again if I take 40, 39, take a group of 2 digits, alternatively add and subtract, and so on up to how much it will be? 39, 38, 37, 36, 35, 34, 33, 32, 31. I hope it is clear, right? 30, 30, 29, again minus 1, 30, 29, 28, 27, 26, 25, 24, 23, 22, 21. Till 21 I will get it. Next, 2019. Are you all with me? 2019, 18, 17, 16, 15, 14, 13, 12, 11. So instead of doing that one, 11 and so on, from here to here, 11 to 42, 11 to 42, 32 groups are there. 11 to 42, 11 to 42, it is nothing but 32 digits are there. So take a group of 2 digits, alternatively plus and minus 1, plus and minus 1, plus and minus 1. From 11 to 42, total digits are 32 digits. 32 digits. 32 digits is nothing but 16 groups. Each group the net value it is 1. Each group the net value it is 1. Are you all with me? So 16 into, that means this entire answer will be 16 into 2, 32. From here 32. Alternatively take a group of 2 digits, alternatively plus minus, alternatively plus minus. So what will be the answer? Answer is 23 minus 1 is 22, 67 minus 45 is 22, 10 minus 89 is minus 79, plus 32 minus 79 divided by 101. I hope the logic is clear. Why little bit of complication is required? Because first I wrote a single digit number, then I wrote a 2-digit number. 10, 11 and so on up to 42. From 11 to 42 there are 32 digits are there. That means there are 16 groups are there. Each group is of 2 digits. Each group is of 32 digits are there. So I took it into a group of 2 digits, 16 groups. Each group is giving you 1, 1, 1, 1. So 1, 1, 1, 1, 1. So total 2 into 16, 2 into 16. I hope it is clear, right? Extra 10 is there, 10 minus 89, 67 minus 45, 23 minus 1. If you calculate it, you will get the answer. Idea clear? Little bit of again a calculation intensive problem. Idea is 10 square divided by 101 is minus 1. Idea clear? Next one. Find the remainder when the number is divided by 99. Number is divided by 99. So 99 is nothing but 10 square divided by 99, it is 1. It is 1. That means 42, 41, 40 and so on up to 11. 11, 12. Take a group of 2 digits, add them. Take a group of 2 digits and add them. Till here I will get 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by 99. So these, take a group of 2 digits, take a group of 2 digits, take a group of 2 digits, take a group of 2 digits and add them. Take a group of 2 digits and add them. So answer is nothing but a remainder of 23 plus 1 is 24 plus 45 plus 67 plus 89 plus 10 plus from 11 to 42. From 11 to 42. Total how many numbers are there? 32 numbers are there. N by 2 into first term plus last term. 32 by 2 into 11 plus 42. So what will be the answer? 20 plus 40, 60, 60 plus 60, 120, 120 plus 80, 200. So these 200 plus 4 plus 5, 9, 9 plus 7, 16, 16 plus 9, 25. 25 plus 10 plus 32 by 2, 16, 16 into 53 divided by 99. Whatever the answer that you will get it, that itself is the answer. Little bit of calculation intensive, but the method remains the same. What is the method? 10 square divided by 101 is minus 1. 10 square divided by 99 is plus 1. Entire concept uses this one. Remainder 1. 10 square divided by 101 is minus 1. 10 square divided by 99 is plus 1. Divided by 99 is plus 1. Idea clear, right? I hope the approach is clear. Next one. Next, another beautiful question. What is the remainder when n is divided by 441 into 271? Well, first we will discuss the concept. Suppose if I take 10 power 5 divided by 41, 10 power 5 divided by 41. Let us see what is happening. So 41 into 271. 41 into 271. If you do it, you will get a number that we will discuss a little later. Now 10 power 5 is nothing but 10 square whole square into 10 power 1 divided by 41. 10 square is 100. 41 2s are 82. 18 square is 324 into 10 divided by 41. 41 8s are 328 minus 4 minus 40. Minus 40 is nothing but 1. Minus 40 is nothing but 1. Are you all with me? Minus 40 is nothing but 1. Again I am solving. 10 square whole square into 10 divided by 41. 100 divided by 41. 41 2s are 82. 18 square is 324 into 10 by 41. 41 8s are 328 minus 4 minus 40. 41 minus 40, it is 1. So these 1. I hope it is clear, right? Similarly, suppose if I do by 271. 10 power 5 divided by 271. What is the last value that we got it? So 10 power 5. 10 power 5. So here if I do 10 power 10 cube into 10 square divided by 271. 10 cube is nothing but 1000. 271 3s are 813. 813 means 187. 271 into 3 is 3. 3 7s are 21. 21,813. So remaining is 187 into 100 divided by 271. So if you do, you will get again plus 1. You will get again plus 1. I hope it is clear. You don't need to do all this. Very important concept is there that we will discuss, right, little later. 10 power 5 divided by 41, it is 1. Remember this, 10 power 5 divided by 41 is 1. 10 power 5 divided by 271 is 1. So what we will do is, first we will calculate what is 41 into 271. Some important conclusions can be drawn. I hope it is clear. So what I wrote here, 10 power 5 divided by 41 is 1. 10 power 5 divided by 271, it is also 1. Let us see whether it is there or not. 41 into 271. Let us calculate what is 41 into 271. So these are nothing but 40 plus 1 into 271. 0. 1 4s are 4. 27 4s are 108 plus 271. So these are nothing but 1, 1, 1, 1. It is 5 ones. It is 5 ones. It is 5 ones. So 41 into 271 is 5 ones. Now how am I using this one? So these are nothing but 10 power 5 minus 1 plus 1 when divided by 41. Can I write like this? 10 power 5 minus 1 is 10 square minus 1 is 99, 2 nines. 10 cube minus 1 is 3 nines. 10 power 5 minus 1 is 4 nines. 10 power 5 minus 1 is 5 nines plus 1 divided by 41. 5 nines is 9 into 5 ones. 9 into 5 ones. 5 ones is divisible by 41. I hope the idea is clear. For 10 power 5 divided by 41 is 1. 10 power 5 divided by 271 is 1. Either you can do by using remainder concept or you can multiply both of this. 41 into 271 is 5 ones, right? So 10 power 5 subtract 1, add 1. 5 nines plus 1 divided by 41. 5 nines is 9 into 5 ones. 5 ones is divided by 41. Idea clear? Now where am I using this concept? 10 power 5 divided by 41, which is nothing but 1. That means 5689. 5689. If I take 568789, a 5-digit number 2 times, what will be the answer? Start from rightmost, take a group of 5 digits and add them. So what I will get? I will get 2 into 568789 divided by 41. I hope the idea is clear. That means if 56789 is written 2 times, I got 2 into 56789. If it is written 100 times, I will get 100 into 56789 divided by 41. Whatever the answer that you will get, that itself is the answer for the question. Same approach also holds good. 56789 written 2 times is 2 into 56789. If it is written 100 times is, right, answer will be 100 into 56789 divided by 271. Idea perfect clear, right? A 56789 written 2 times is 2 into 56789. If it is written 100 times is 100 into 56789. Idea clear, right? Little bit of advanced level questions. Next one. Now another concept. Any single digit written p minus 1 times, any single digit written p minus 1 times is always divisible by p, is always divisible by p, is always divisible by p if p is prime, if p is prime. P is not equivalent to 2, 3 and 5. That means if 2 is written 40 times, when divided by 41, remainder is 0. When 3 is written 66 times, when divided by 67, what is the remainder? 0. Any single digit written P minus 1 times is always divisible by P if P is prime. P not equivalent to 2, 3 and 5. This I am going to use in this concept. Now, if you see here, find the remainder when n is divided by 41. N is divided by 41. Can I say 41 into 271? It is nothing but 5 ones. Suppose remainder when 2 is written 5 times. 2 is written 5 times divided by 41. This can be written as 2 into 5 ones divided by 41. 5 ones is divided by 41. What will be the remainder? 0. That means any single digit written 5 times, any single digit written in groups of 5, any single digit written in groups of 5 is always divisible by 41, 271. Any single digit written in groups of 5, it is always divisible by 41 or 271. Extremely important point. When divided by 41, any single digit written in groups of 5 times it is 0, 10 times it is 0, 5 24s are 120 times it is 0. So remainder is 222 divided by 41. So 41 5s are 205. Remainder is 17. First one answer is 17. Similarly, 222 divided by 271. 271 zeros are 271. Answer is 222. I hope the idea is clear. Any single digit written in groups of 5 is always divisible by 41 and 271. Any single digit written in groups of 5 is always divisible by 41 and 271. So if it is 5 times 0, 10 times 0, 120 times 0, remaining is 222. 41 3s are 120. 41 3s are 5s are 205. Remainder is 17. Please make a note of this point. Today's class is a very high advanced level of how to use the divisibility rule for the concepts that we discussed. 41 into 271. This is the concept. Next one. Next, 73 into 137. If I do 73 into 137, I will get this value, 10 power 4 plus 1. You can do multiplication and you can check it out. 73 into 137 is 10 power 4 plus 1. So if I do 10 power 4 divided by 73, here it is nothing but remainder 1. 10 square into 10 square divided by 73. 73 ones are 73. Remainder is 27. 27 into 27 is 729. 729 divided by 73. 73 tens are 730. Negative remainder minus 1. Negative remainder minus 1. I hope it is clear, right? It is 137. Right? Similarly, you can do 10 power 4 divided by 137. This also will give you minus 1. Suppose if I take question like this, 1 2 3 4 1 2 3 4 divided by 73. So here it is 1 2 3 4 1 2 3 4. So here it is 1 2 3 4 into 10 power 4. 1 2 3 4 1 2 3 4 divided by 73. 1 2 3 4 into 10 power 4 plus 1 2 3 4 divided by 73. This is minus 1. Minus 1 plus 1 is 0. Very, very important key point. Any 4-digit number written even times, any 4-digit number written even times is always divisible by 73 and 137. Please make a note of it. Any 4-digit number written even number of times is always divisible by any 4-digit number written even number of times is always divisible by 73 and 137. Extremely important concept based upon the multiplication of 73 and 137. 10 power 4 divided by 73 is minus 1. 10 power 4 divided by 137 also it is minus 1. Idea clear? Now based upon this one, remainder 1 2 3 4 1 2 3 4 divided by 73. Any 4-digit number written even number of times. What is the concept? Any 4-digit number written even number of times. Any 4-digit number written even number of times is always divisible by 73 and 137. So this is 0. 30 times is nothing but even number of times. 30 times is nothing but even number of times. First one and second one answer is 0. Because of this concept, any 4-digit number written even number of times is always divisible by 73 and 137. Idea clear, right? I hope the idea is clear. Next one, right? Next one, these are another variety of question. N is written as 77777 50 times. What is the concept? Find the remainder when n is divided by 17. Remainder 10 power 8 divided by 17. If you do it, you will get minus 1. You will get minus 1. Right? There are two conclusions. First conclusion is any single digit written in groups of 16 is always divisible by 17 because 17 is a prime number. 17 is a prime number. So in groups of 16 3s are 48, remaining is 2. 77 divided by 17 4s are 68, remainder is 9. Any single digit written in groups of 16 is always divisible by 17. 17 is a prime number. So 17 means written in groups of 16. 16 3s are 48. Remainder is 77. 17 4s are 68. What is the remainder? 9. I hope the idea is clear. Similarly, find the remainder when n is divided by 19. Two ways you can do. 10 power 9 divided by 19, it is minus 1. Or any single digit written in groups of 18. Any single digit written in groups of 18 is always divisible by 19 because 19 is a prime number. So in groups of 18 4s are 72. How many are left? 3 18s are left. 3 8s are left. 888 divided by 19. 19 4s are 76. 128. 128 means 19 6s are 114. Remainder how much it is there? 14. Any single digit written in groups of 18 is always divisible by 19 because 19 is a prime number. Very advanced level questions. This class I want you to do a recap once again whenever you get a time period. 10 power 9 divided by 19 is 1. Idea clear, right? Next one, same idea. Any single digit. What is the idea that we are using? Any single digit written p minus 1 times. Any single digit written p minus 1 times is always divisible by p if p is a prime number. P not equivalent to 2, 3 and 5. Any single digit written in groups of p minus 1 times is always divisible by p. P is a prime number. Here p is 67. That means written 66 times. Any single digit written 66 times is always divisible by 67. 67 2s are 132. Remaining is 3 5s. 555 divided by 67. Whatever the remainder that you get it, that itself is the answer. I hope the idea is clear. What are the concepts that we discussed today? Any single digit written p minus 1 times. So we discussed the application of below problems, application for divisibility rule for 27 and 37, divisibility rule for 7, 11, 13, divisibility rule for 259, 176 and 351, divisibility rule for 16, divisibility rule for 99 and 101, divisibility rule for 17, 19, 67, divisibility rule for 41 and 271, divisibility rule for 73 and 137. What is the last concept that we discussed? Any single digit written in p minus 1 times, is always divisible by p if p is a prime number. Any single digit written p minus 1 times is always divisible by p if p is a prime number. Advanced class, kindly listen to each and every problem. Whatever I discussed, understand the idea in every question and try to solve. Some questions are calculation intensive, that be little careful, like this question, right? It is calculation intensive. Here also the concept, any 2-digit number written even number of times. I hope you enjoyed the class. In case if you enjoyed the class and if you think that these concepts are not taught in any of the coaching centers or YouTube live class and you understand the way I teach, you can call my number to buy the course at a discounted price. Thanks a lot. With love, Anil Nair.